Good morning, almost afternoon. I just had major technical difficulties, but I apparently fixed them. Yay, me! We'll see. Nobody should be crying. Oh, it is Cinco de Mayo. It's my nephew's birthday, too, which is kind of fun. And my cat is joining in, so I don't know if you can hear my cat meowing, but I've already tried to get him out of the room once, and he refused. So I'm just going to leave him for now. So, all right. Sometimes I can't figure out why I'm in our 256 notebook instead of our 250. Oh, no. Whatever I just did was bad. Don't do that. Okay. While we're waiting for everyone or for me to get organized, try this warm up. And try it without looking at your notes, hopefully. So can you see my screen? Yay.
I'm on my phone today, so I might be going in and out.
Okay. Thanks for letting me know. So try those two problems. And even you might want to think about how you would do it visually if you did that. And then you think about how you would share it with the rest of the class. Your reasoning. All right. And just so you know, I have to let you guys out at exactly 1:20, if not before, because my son has an appointment at a doctor. So I got to run to that. So, another thing I have to tell you is it's this time of year, there's just a million things happening. I'm sure you feel my pain, right? So, tomorrow morning, I have to change my office hours instead of 8 a.m. I was still trying to figure out when I can do them because my meeting schedule has gone bananas as well. So I'm going to look at my calendar and see if I can move them. I am still having office hours tonight. No worries. Tonight we're on 7:30 to 8:30. But tomorrow I have, my gosh, why can I just not look at a day? Okay, so. Okay, so tomorrow it doesn't look like I have a meeting till later. So I could do office hours in the afternoon. I could even do it like 2 to 3 tomorrow if we need it. So I'll just switch them from 8 to 9 to 2 to 3. Okay. So just so you know, in case you need me, we'll do that. My daughter, they're having some senior award thing at 8 a.m. tomorrow. So I can't miss that. So So we'll just rearrange a little bit. I would do it right after our class, but I feel like I would be starving to death. So I'll wait and do it at 2. Okay, so you're trying those problems, thinking about how you would explain it, draw a picture, something. All right, how many of you are done with both of the problems? Excellent. How many of you are done at least with one of them? Okay, so if you just got here, I can't take your vote into consideration, just FYI, because it's already 12:06. So let's go over these. So convert 74 inches to feet, show all your work. And it says no decimals or improper fractions are allowed for your final answer. So what do you think about that one? Who would like to be the brave soul to explain, show your work, whatever you did on that one?
I can share.
Okay.
So what I did the conversion. I don't know y'all can see this, but I did 74 inches over 1 feet equals to 1 feet to 12 inches because I know there's 12 inches in a foot, and so I just cross multiply and I got 74 over 12, and I divided 12 into 74 to get 6 and 2/12, which simplify would be 6 over 1/12. And then I did a little picture too.
Tell me about your picture.
So I since I know that there's 12 inches in a foot, I just added 12 until I got close to 74, which was 72. And I know that like 74 minus 72 is just 12 inches left over. I mean 2 inches left over. And so I put 2 inches out of 12 inches, which is still 2 out of 12 and then just simplify, it will still be 6 feet over 1 6.
All right, so what are your units on your answer?
That'll be inches. I mean feet. Sorry, that'll be feet.
Feet, very good. Now, the only thing I want to do is we're on the very, very beginning of your math, the top left-hand corner,
Okay.
where it says 70, what does it say? 74 inches over 1 foot.
Yeah.
I don't think there should be feet there.
Just be 1.
So it should just be 1. 74 inches over 1, just a whole number, right? So then you can see, and is that a multiplication sign between them?
No, it's an equal sign.
It needs to be a multiplication sign. So put a multiplication sign between them. There you go. And that's how you can see, the only way you're allowed to cross out those inches is if you're multiplying, right? Otherwise, you're not allowed to cross out those inches. So your mathematics is correct, but just attending to precision on that notation. Okay, anyone else have a comment on Bethel's? Okay, I thought Bethel did a great job doing a picture too, by the way. Thumbs up. That was awesome. Good job. Okay, did anyone do it a different way? Even if it just looked different. I mean, I hope we all got the same answer, but maybe a different procedure.
I kind of did it a little bit different. First, I just knew that 1 foot equals 12 inches. And so I divided 74 inches by 12 inches. And then 6 came out perfectly because 12 times 6 equals 72. So I knew that there was for sure 6 feet. And then I just said that there was 2 inches left over. So my answer was 6 feet, 2 inches. Is that okay? Or do you want the entire answer to only be in feet?
Yeah, it depends on how the question is asked, right? So sometimes they will accept the answer in feet and inches. But since this one said it wanted it all in feet, then you would have to convert that. And one of the biggest mistakes our students make is they do it on, they do it by hand and they get stuck, right? Because they get pretty good at doing something like this, depending on their age. So they do 74 divided by 12, and they get 6. And then they get this, and they add this, yeah? And then they go 12, 8, 0, 6, 72, 8, 0, right? And so then they'll write, is that 8 again? Yeah. So they'll write something like this. They'll go, oh, it's 6.2 feet. Is that accurate? Is it 6.2 feet?
No.
No, it's not. And coincidentally, you see that too, right? Which is troubling because they're like, yeah, there were 2 inches left over. That's where they are, 6.2. But mathematically, that's not accurate because, right, we know there's 12 inches in a foot. So 2 inches as part of 12 would not be 2/10. It's 2/12. So you have to be careful. So that's the only thing you have to be careful of with that, McKenna. So it is 6 feet 2 inches. I have no argument with that. But if we're trying to write it in only feet, we would have to use a different strategy.
Okay, thank you.
Yeah. Anyone else do it differently? Did anyone do it like this? Sometimes I see this. Let me see if I can do it. 1 foot is 12 inches. So how many feet are 74 inches? So cross multiplying using proportional reasoning, right? Yeah, did anybody do it like this? No. Here's a way I've seen kids do it. Kids have done it like this. Okay. 1 foot, 12 inches. 1 foot, 12 inches. And then underneath they'll go, okay, I'm at 24, right? And then they'll go, okay, I'm at 36. And then they'll go, okay, I'm at 48. Right? Meanwhile, they're still accurately labeling, right? Kind of like a tape diagram, yeah? Like we did in 256. Like Bethel did, but I don't think Bethel actually did it this way. I think she just drew it that way afterwards, right? Yeah.
That was kind of what I was going with.
Yeah, some kids actually use this as their problem solving method. They go, okay, 1 foot is 12 inches. So then 2 feet is 24 inches. 3 inches is 36. Sorry, 3 feet is 36 inches. 4 feet is 48 inches. 5 feet is 60 inches. 6 feet is 72 inches. And then I have those 2 feet left over. And then some of them even draw like our fractions, right? If we have 1 foot and I mark those 12 inches, so there's 12 inches. If I have 2 inches, that's 2 out of 12, and then they will simplify it to the 1/6. So using all those strategies we did in 256, because they're learning those at the same time, right? And we don't want them to be disconnected. Okay. How about the second problem? That one was a little bit different, right? Who wants to share that one? How they did it? Don't everybody volunteer at once. I don't want the answer, Sunita. I want your explanation. That's what I want. That's what we're here for. Right? Mathematically, you should be able to do that. Tyler, I'm ready.
All right. So what I did was to make things a lot simpler, I just added the pounds with the pounds and then the ounces to the ounces. So I took 3 pounds plus 5 pounds, which gave me 8 pounds. And then I added 4 ounces plus 13 ounces, which came out to 17 ounces. And I simplified that knowing that 16 ounces is 1 pound. So I'd have 1 pound, 1 ounce. And then I added that to the previous 8 pounds to give me, so 8 pounds plus 1 pound plus 1 ounce, which gave me 9 pounds, 1 ounce.
Anyone do it Tyler's way? Did anyone else do it that way? Yeah, a lot of people are shaking their heads or holding their hands up. Yeah. Anyone do it differently?
I did it the same way Tyler did, but just to verify, I did like it was a longer way. I just converted everything to ounces, and then I added the ounces up. Then I converted back to pounds. But that was just me for verification.
Anyone do it that way? Converted them all to ounces? Madison's saying yeah. Amanda's saying yeah. Yeah, you could do that. So, and it might, it's a great verification, or it might be the way your brain works, right? That's totally fine. Anyone do it differently? You did the same, but you forgot about 16 ounces. So did anyone do it where they did, like, let's say they added them and they just wrote 8 pounds, 17 ounces. Did anyone have that as their answer? Yeah, it's a very, very common. Is it correct? Yeah, it is mathematically correct, right? It's not wrong. It's just not how we write things, right? So once we have enough for one size, we move up to the next size. What does that sound like?
Candy factory.
Candy factory. Welcome back. Yeah, it is. It's the same scenario, right? As regrouping. Same thing. If we want the fewest number of packages possible, that's what we would do. Yeah, Karina, that's perfect. And your answer is not wrong. Like I said, it's just not conventional, right? So good job. I have had kids do the strangest pictures with this one. This is what I had a kid do once. Okay, this is going to be pounds. Okay, that's what they told me. And then they said, this is going to be ounces. And I was like, okay, I'm with you so far. And then they went, okay, so I have 3 of these and 4 of these, and then I have 5 of these, and I have 13 of these. And then they said, I put them all together. And then I said, I also know that 16 of these equals 1 of these. Yeah, so they put them all together. They did this 4, 8, 12, 16. And that was their picture. 9 pounds, 1 ounce. Thanks for that face, Karina. What does that look like to you? What does it remind you of?
That base power of 10 we did in 256.
Base 10 blocks, right? Those are base 10 blocks, even though they're not base 10, right? Because now we're in pounds, but they use, this is actually fairly algebraic thinking, right? Find a symbol that represents one thing, find a different symbol that represents the other thing, and then figure out how those two things are related. This is great algebraic thinking. Yeah. If your student does this, you should be so impressed. This is high level thinking. A lot of people think it's the reverse. They think it's low level thinking. And that your other way of doing it, converting them all to ounces and then converting them back, is high level thinking. One is really thinking and one is just procedural, right? And with procedures, we're thinking less. Right? So be careful not to put judgments on your students. By the way, I don't care if they do it procedurally or high level thinking. I just want them to have some strategy to do it. Right? And on different problems and different topics, they will have different things that they're good at or bad at. Right? So the more ways we can see it, the better. Anyone else have a different way? All right. Here's boring ways, right? I just showed you, right? Okay, try this real quick. What unit in the metric system, so the metric system and the US system, would be most appropriate if you're measuring first the length of a pencil, then the weight of a person, then how much water in the backyard swimming pool? So come up with your metric unit and your customary system unit for each of those. All right, do you got them all finished? So for the first one, the length of a pencil. What did you say for either the US or the metric system?
I put for the US to measure the pencil by inches, and then for the metric to measure it by centimeters.
How many of you agree? Yeah, absolutely. I agree too. How about the next one? The weight of a person.
I put for the US pounds and kilograms for the metric.
Did anybody put grams for the metric? It's okay if you put grams. It might, because you're a little less familiar with that. Grams don't weigh very much, right? So, but kilograms weigh 1,000 times as much. So those of you that grew up with the metric system, when you report your weight, do you do it in kilograms?
Yes, I think only because I'm trying to remember my experience in Mexico, that they used a lot of kilograms to measure the weight of things, percents, food, things like that.
Okay, good. Yeah, I'm not sure. So kilograms. Vanessa is confirming you. So kilograms. Excellent. Okay. How about how much water in a backyard swimming pool? What do you think about that one?
I put gallons for the US and then either liters or kiloliters for metric.
Yeah, what do you guys think of that? Liters or kiloliters for the metric? Yeah, excellent. All right. All right, so I just wanted you to see. Now, we didn't talk much about the metric system yesterday, but I did hear this in a couple rooms. Some people remembering King Henry died by drinking chocolate milk or something similar to that. How many of you have heard something like that? Yeah, so it's just a way to remember the prefixes. So kilo, hecto, deca, the base unit, which has no prefix, deci, centi, and milli. So the king is for kilo, the Henry is for hecto, deca is died, the base unit is by, drinking is deci, chocolate is centi, and milk is milli. So, and these are larger units of measure, these are smaller units of measure. And you can see that, for example, the meter compared to a decameter, the decameter is 10 times larger. A hectometer is 100 times larger, and kilo is 1,000 times larger. That's what those prefixes mean. Kilo means 1,000. Hecto means 100. Deca means 10. Whereas deci means 1/10. Centi means 100th. And milli means 1,000th. So, and it's all compared to the base unit. Okay. And so this is base 10, just like we're familiar with. So, and the bad part about it being base 10 is a lot of teachers teach just remember these. Sometimes use a capital D for that, just to remind students it's not the same. And then when they do problems, they just have students do this when they're doing things mathematically, and then the student has no idea what's actually happening mathematically. So you have to be really careful, right? If you're going to teach a method like that. I didn't tell my students they couldn't do it because I didn't have them until 8th grade. So they had already learned this somewhere else. And so in 8th grade, instead of trying to unteach them that, I just said, okay, if you're going to do that, you need to be able to explain mathematically what's happening, right? And if they could do that, then we were okay. If they couldn't, then I made them use a different method. So 1 kilometer is 1,000 meters. 1 meter is 100 centimeters. 1 centimeter is, how many? 1 centimeter is 10 millimeters, right? 1 kilogram is 1,000 grams. 1 gram is 1,000 milligrams. And 1 liter is 1,000 milliliters. So you should be able to fill those in just by thinking about what those prefixes mean. Which one is the larger unit? Which one is the smaller unit? How many of you, that's like a brief refresher there? You're like, oh yeah, this seems familiar. Yeah. Okay. And I gave you a conversion sheet. I don't think you really need the conversion sheet, you know, you might need it for your homework, but you definitely can't use it on the final. But there's not a lot of them. It's not going to make or break your grade if you miss all of the measurement ones. You know, if you miss them all, maybe that'll be the difference between an A and a B, you know, on the final, but that's it. Like, it's not going to make or break you. Some of you are like, yes, that will break me. Don't say that. Yeah, I see your faces. Okay. So these are the ones we did yesterday. I just wanted to make sure I went over any of them that people were confused on, because I did have some wrong answers on the exit ticket. So on these three, 9 meters is how many centimeters, 2,000 millimeters is how many meters, 5 kilometers is how many meters. You can use the same techniques you did in the US system. You don't have to use the moving the decimal point strategy. Conversions are conversions are conversions. It doesn't matter which system you're in. So for example, if you used the technique of, like Bethel showed us in that first one with our inches problem, you could say 9 meters over 1 as just a whole number times, well, do I know a relationship between centimeters and meters? Just like I knew a relationship between inches and feet, now I need to know a relationship between meters and centimeters. What's the relationship between meters and centimeters?
One meter is 100 centimeters.
Very nice. 1 meter is 100 centimeters. Then you can see those units simplifying, the meters simplifying, and you end up with just 9 times 100. So it's 900 centimeters. So that same strategy works. But do you see how now the mathematics and the idea is intact? Instead of teaching 2 different methods, one for the US system and one for the metric system, you teach one method if you need to teach the method, or you can just tell them they could draw a picture to solve this, right? They could totally draw a picture to solve this. Same thing, right? Okay, so 1 meter, here's 1 meter. And I know that's 100 centimeters. They have to know that. So if I have 9 copies of this, I'm not going to draw it, copy 9 times. So then it must be 900 centimeters. Look at that, copies of again. It's back. Yeah, you're so excited. You're like, she really just said that. Two things in one day. She brought up Candy Factory and copies of in one day. Must be the end of time right here. Okay. Thanks, Karina. All right. So do you need me to do 2,000 or 5 kilometers? We can if you want. I'll show you what I see students do that's nonsensical, that they don't know what's happening. So they go like this, 2,000. So then they go like this. Oh, here's my decimal point. Right? I'm not saying they're wrong. I'm saying, why did you do that? Right? Like, what was that about? Oh, I shifted over 3. Why? Because? Well, because why? Mathematically, what's happening? I don't know. And then I push it, right? And I ask him again, well, mathematically, what's happening? I'm multiplying by 1,000. Really? You're multiplying by 1,000? No, you're not. You're dividing by 1,000. Why are you dividing by 1,000? I don't know. And then they'll go like this. Oh, because King Henry died by drinking chocolate milk. Because I'm going from here to here, and that's 1, 2, 3. So that's why I did it. 1, 2, 3, 1, 2, 3. Yeah. Which is true. That is why they did it. But they don't understand mathematically why they did it. So then what I notice they actually do come test day is they don't give me this answer. They give me this answer. Yep, 1, 2, 3, 1, 2, 3. Right? It's because they're not thinking about these units. They're just knowing they have to move their decimal point. They're not thinking about what's happening. So that's why I'm not a huge fan of that method. I don't know if you just heard my stomach growl through the microphone, but it was crazy loud. Did you hear it? Michaela, did you hear it? Oh my goodness. Yeah, I was worried because my microphone is kind of low, right? Yeah, I'm hungry. Let me tell you, I am hungry. Yeah, you're like, let's just take a break. You can go eat. It's all right. Just kidding. My son, his doctor's appointment, he has to fast for. So I'm fasting with him. Yeah, so it's very sad because I would love to eat, but I'm trying not to because he's been up forever and he's like, I am so hungry. I'm like, yeah, you should have stayed in bed. That's what I would have done. Yeah, right? Yeah. I hope he's still remembering that he's fasting. Okay. Any questions? This would be 5,000. I still can't believe you heard my stomach growl. I bet it'll be on the recording. That will be very fun. Yeah. Nice. It's going to growl again, so just be prepared. Third grade standards. Oh, by the way, let's go back here. Let's go back here just because it's adorable. How cute is that? Yeah, you're welcome. Did anybody have anything to share now that it's 12:35? It's still We Share Wednesday. I've shared plenty, including my stomach growls.
I have something to share.
I'm ready, Andrea.
Well, the reason I don't have my camera on is because we just got a six-week-old puppy yesterday. So he's been a handful all night.
Yeah. So, but you're not going to show us the puppy? How can you do that to us? Right? Is anyone with me? Like, how can you say you got a puppy and then you're not going to show it to us? Oh, okay. I'm ready.
I don't know if you can see.
Oh, now it's sleeping perfectly, right?
Yeah.
Oh my gosh. Okay, what kind of puppy?
It's a German Shepherd.
Oh, that's going to be a beautiful dog. So, did it sleep at all last night?
No, I woke up every hour of the night.
I'm not laughing. I am laughing. So, Andrea, if you don't have any kids, that's your first training with having a child right there.
Yeah.
Am I right? Am I right, Sarah? Yeah. See? Yep, Brianna's agreeing. Yeah. People don't realize how much work puppies are. They are insane. And then the chewing begins. 6 weeks seems really young. Did you say 6 weeks? Did I dream that?
Yeah, 6 weeks. A little over 6 weeks. Yeah, he bit one of the speaker cords right now. I just noticed he ripped it.
Okay, you got to be careful because I just was talking to a breeder about dogs being taken away before they're 10 weeks old. And dogs being taken away before they're 10 weeks old tend to be horrible biters because when they're with their mom in the litter, that takes care of it. Because if you bite mom, mom's not going to feed you, right? And then siblings won't play with you. You know, the other litter mates won't play with them. So it like teaches the dog. I have a friend who just got an 8-week-old puppy and she's like, this dog is biting like mad. And so the breeder was saying, okay, this is what you have to do. So Google it and look up what you have to do to make them not bite anymore because they'll still chew everything. But I guess when they're so tiny, when you get them, like rescues have that problem a lot because they just go crazy because they're not taught not to bite. I'm not saying bite your dog, just in case you thought I said that. Have you ever heard those crazy parents that are like, I bit my kid so they wouldn't bite somebody else? Yeah. Thanks, Karina. You've heard those crazy parents. Yeah. Don't bite your dog. That's not what I'm saying. But yeah, they're crazy. Yeah. Puppies. Well, thank you, Andrea, for sharing. I'm so happy. Good luck with that dog. I hope you don't plan on sleeping the next month.
Yeah, I don't think I'll be sleeping for the next like 3 months because they say that at 4 months they start sleeping through the night.
I wouldn't survive that long. All right. Anyone else have news? I'm so excited for the puppy. No. All right, you're getting close. What is that, Jessica?
Flowers that my boss got us for teacher appreciation.
Oh, they're so pretty. Is it like a little tiny flower? Oh, it's so
Yeah.
cute. That is so sweet. Where do you work, Jessica?
Bridges and Preschool in Chandler by the campus.
Nice. That's awesome. Anyone else getting teacher appreciation stuff this week? Betty, did you get anything good, Betty?
Yeah, food.
That's always the best.
And they told us that we could leave like as soon as the students leave. So the students had early release today, so I left.
Nice. Sydney got some cute cookies.
I was gonna share just because I mean I was happy about it, but I thought I wasn't gonna graduate this summer. Well, I thought I wasn't gonna graduate, so I was kind of upset about it. But I got an email yesterday that I got approved to graduate if I finished my classes during the summer. So
Yay! Hooray! Great job, Betty.
thank you.
That is definitely something to share. Very exciting. Okay, anybody else? I'm so happy we went back. And you know, it was these little people with their ice creams that made you want to share. It's true. Okay. Okay. So the reason I wanted to go back is because what we're supposed to be talking about today is area and perimeter and circles. That's what we're supposed to be talking about. But I didn't want to leave the metric system in the dust. So I wanted to make sure you understood some things about the metric system. So in third grade, geometric measurement, understand concepts of area and relate area to multiplication and to addition. So they have to recognize area as an attribute of plane figures and understand concepts of area measurement. A square with side length 1 unit is called a unit square, is said to have 1 square unit of area and can be used to measure area. So we're going to talk about that first. That's like step 1 of area. Then a plane figure which can be covered without gaps or overlaps by n unit squares is said to have an area of n square units. So those two are connected. Now, the relationship between area and perimeter is very challenging for students to understand. So what's area and what units are used to measure area? We just talked a little bit about what area is. And do we all understand why area is measured in square units? I'm glad that I see some people like not responding, or I don't know. So area is measured in square units because it is two-dimensional that we're measuring. So for example, let's say I have this shape and I made it a weird shape on purpose, right? Because if we make it only perfect shapes, remember, students have a hard time understanding. I don't know why it's erasing the whole thing instead of, they have a hard time understanding what we're talking about if we only do perfect shapes all the time. So when we're measuring area, we're actually putting squares, covering the shape with squares. That's what we're really doing. And then we could count the squares that would tell us the area. But if you think about it, we're measuring in 2 dimensions, this dimension and this dimension. So we have a length and a width, or a base and a height. So that's why it's 2-dimensional. Some of you remember some area formulas, right? Who remembers an area formula? Any area formula? Tell me what it is.
Base times height.
Thanks. And what's that the formula for, Betty?
Triangle? Or right? No. Why am I having that? I don't know.
It's a rectangle. You're right.
Oh.
Sometimes people call it length times width. Has anyone heard that instead of base times height? Yeah. Some people learned it one way. Some people learned it the other way. Doesn't matter. It's okay. Because in a rectangle, the height is the same as the width and the base is the same as the length. So it's okay. But if you think about, let's make this an actual rectangle. Okay. So if we had an actual rectangle, and we'll make it a simple one. These are all the same length. Perfect. You can't tell, but it's true. It's just Zoom that's making them look like that. Okay, so let's say these are each centimeters. So if we have 1, 2, 3, 4, 5, 6 centimeters for our length, and 1, 2, 3, 3 centimeters for our height or our width, when we multiply, this is the part your teachers left out sometimes. When we multiply 6 centimeters times 3 centimeters, we're really multiplying the 6 and the 3 to get 18. And then we're multiplying the centimeters times the centimeters to get square centimeters, right? When I have the same thing repeated, I can put that little 2 there. Yeah? So that's why it's squares, and we're counting them. So they're really, if we counted these, there are 18 of them. So if we covered this shape with square centimeters, we would have 18 of them perfectly covering the shape. So that's why it's measured in square units, because it's measuring 2 dimensions, length and width. Okay? What's perimeter measuring? Who knows what perimeter is measuring?
Is that like the length of the outside of the shape?
Absolutely. Good job. So did anybody watch police shows? Yeah. You ever watched a police show and they come on and they say, we have the perimeter surrounded, right? Does that mean they're in the building? No. It means they're around the outside of the building, right? So yeah, perimeter is the distance around the outside. So if we had that same shape, see if I can replicate it fairly quickly. If we have that same shape, that's 6 centimeters by 3 centimeters, what is our perimeter of this shape? We're only looking at these guys along the outside. What's the perimeter of this? Yeah, McKenna put it in there. 18. Now, is it 18 centimeters squared? No, why not?
You're only adding the centimeters, you're not multiplying them.
Very nice. When I do this, I'm doing 6 centimeters plus 3 centimeters plus 6 centimeters plus 3 centimeters. I'm only adding them, so my units are not getting multiplied. Also, if you think about it, I'm just walking around this room, right? I'm not covering it with squares. I'm just walking around the outside, so I'm only measuring linearly. I'm only measuring one dimension. Okay? But it's nice that you're thinking about it, you're not multiplying, so there's no way it'll be square units. But sometimes teachers, textbooks, people forget to put the units on during the actual computation, and then that idea gets lost, right? So they just write 6 plus 3 plus 6 plus 3. And then students are guessing what units to put on the end. Is it square units? Is it cubic units? Is it just regular units? What do I put on there, right? So be careful. Okay. So here's a nice little thing you can review later about perimeter. Math is Fun is a really good one, and then the dictionary reference. So perimeter is one dimensional, taken around the outside. Now, we call the perimeter of a circle something special. We just call it the circumference because that edge is curved, okay? We're still measuring the same thing, but we don't call it perimeter. We call it circumference. By the way, have any of you ever seen the circumference books? There's children's literature books called Circumference, like Circumference and the Angle of Pi. They're hilarious books. I'll put a link to it in my virtual classroom or in the chat if I have time. So area, here's another different thing. Area is two-dimensional. It represents the number of unit squares that cover the surface of a closed figure. Here's some more third grade. They need to be able to solve real world problems. Find an unknown side length with perimeters. This is the important part. Exhibiting rectangles with the same perimeter and different areas, or with the same area and different perimeters. So differentiating between area and perimeter can be challenging. Some students think that there's a direct relationship between area and perimeter. If the areas are the same, the perimeters will be the same. That is not true. How many of you have ever used geo boards? Anyone ever use them? Yeah, in class, and you were like using rubber bands. You remember that? Yeah. And you started messing around and shooting the rubber bands with your friends, or you broke the rubber bands. That's my nemesis. These rubber bands break all the time. So if you were going to use a geoboard and make a shape that has a perimeter of 6 units, you can all see how this has a perimeter of 6 units, right? Because 1, 2, 3, 4, 5, 6. If we all did this, would we all have the same area? What do you think? I put the geoboard in the chat so you could see this is an electronic version. While we're in virtual town, these are the things we have. If we were in real class, we would be able to use them for real. So you can just put these rubber bands out. You can make them stretch pretty far. Here's the best thing. They don't break, right? They don't break. It's very nice. So, and they come in all these different colors. So it's super fun. Yeah. You can make them do crazy things way easier than you can make regular rubber bands do crazy things. So I'm not opposed. I do not think it's the same as actually putting your hands on rubber bands, right? I don't think it's the exact same, but it's a nice alternative, especially if you have that year where you're online, or you want kids to do something at home, or you don't have rubber bands because they all broke, or you have a very disruptive class. Yeah. And you can't give them rubber bands. That will happen some years, right? Okay. So we could make a perimeter like of 6, and then we could do it this way. Oh, I thought I had that one. There we go. We could do it this way. Anyone have another way that we could make our perimeter 6? The one thing you have to be careful of is if you do something like this, sorry, I made my perimeter not 6. Oh my gosh. That one's not being cooperative. I just need that one to go away now. It hates me now. Why is it just changing my colors? What did I do? I do not know what I did. Anyway, be careful if you go on the diagonals. Is the diagonal a length of 1? Does the diagonal of this have a length of 1? It's not a length of 1, right? Because it would be a right triangle. 1 squared plus 1 squared would be 2. And so it would actually be the square root of 2 would be the length of that diagonal, right? Using the Pythagorean theorem. Yeah. So be careful when you're doing an activity like this that you don't think that. So what I want you to do right now is to use this geoboard that I just gave you and see if you can investigate. I'm going to go back here. If you have the shape that looks just like mine, okay, can you increase the perimeter by 1 unit? Can you increase the perimeter by 2 units? Can you increase the perimeter by 3 units? So think about that and see if you can do it. Okay. I'm going to even put you in breakout rooms while you're thinking. Oh, I should just let you choose your rooms. Can you choose your rooms and then tell me, or just tell me, because I want you to be in your rooms that are like your teams. Okay. So like I know room 7 should be Hannah and Tyler. I don't know why I remember that because I just looked at it before class. It's an illness. And Sarah would be in room 8, but Sarah, go to room, well, I'll put you in room 7 with them. Okay. Can you guys pick your rooms or just want to tell me what room you need to be in? Who was team 1? Do you remember? Oh, Brianna's in team 1.
Me and Vanessa are team 2 or group 2.
Can you guys not choose them? I made it so you could. I thought, oh, I bet I can if I do this. Try it now. Can you do it now? And then if you can't do it, tell me and I'll put you in there.
I'm not sure how to do that.
All right. McKenna, what room did you say?
I'm team 4.
4. Perfect.
Same as, I mean, I can't either, but I'm in team 4 too.
Madison, 4. Perfect.
Perfect. Thank you.
Yep.
I'm in the second one.
Who said that?
Betty.
Sorry, I was looking at something else and I'm like, who said that? Michaela, what are you in? 1?
Team 3.
Okay, 3. Sydney, what are you in? Do you know? Andrea, what room are you in? You know?
I think I'm team 6.
Are you with essay?
Yeah.
Perfect. Sydney, who are you with? I think you're with Karina in room 5. There you go. Sorry about that, Sydney. Okay, now you should have that to go. Hello, welcome back. So you investigated whether you could increase the perimeter by 1 unit, 2 units, or 3 units. So what was your conclusion? I talked to a few rooms, but not all the rooms. Could you increase it by 1 unit? I see some no's and I see some yeses. So Vanessa's a no, Michaela's a no, McKenna's a yes, Betty's a no. So McKenna, how did you increase it by 1 unit?
I am finding the screenshot that we took and I will share it in the chat.
Perfect.
Right now.
Nice. So basically the question was, while McKenna's finding that screenshot, the perimeter was originally 6 units. Could you change it and make it 7 units, right? That was the question. So while we're waiting for that screenshot, let's move to 2 units. Could you increase it by 2 units? I see lots of yeses on that one. That seemed easy, right? To increase it by 2 units. And then how about 3 units? Betty's a no. Betty's a quick no right there. Brianna's a no. So what was happening when you were trying to increase it by 3 units? What did you notice? Or did you notice something altogether when you were looking at them? Ah, there we go. I'm going to download it and I'll see if I can share it. I could have just had you
Ignore
share.
our silly faces in the
I could have just had you.
screenshot.
I know, you got to be careful, right? You're like, why is my face in the screenshot, right? Okay, let me see. See if I can share it on here. Okay. So, does this have 7 units as its perimeter? Yes or no? Can you see the shape?
No.
You cannot.
No, I could see. I was just answering your question.
Okay. No, it doesn't. Betty, why not?
Because the diagonal one is in a 1 unit.
Yeah, so this is really 1, 2, 3, 4, 5, 6, and the square root of 2. So it's 6 plus the square root of 2, because that diagonal is not 1, it's the square root of 2.
Okay, we were thinking that that was when you were only taking the area of it. So that's why we still counted it as only 1, but I see what you're saying now.
Does that make sense? The length of that diagonal is the square root of 2. Yeah. Okay, good. So I think now that you know that, I think you would say that it's not possible, right? Okay. I think I just got kicked out of my own meeting on my iPad. Okay. Oh, maybe I'm still here. Yay. Okay. So what do you notice did anyone come up with a generalization that you couldn't do it for 1 and 3, but you could do it for 2? And you could have even gone further and said, can I do it by 4? Right? Can I do it by 5? Can I do it by 6? What do you think as a general statement? Anyone?
You can't increase the perimeter by odds, but you can increase it by even numbers.
Yeah, why? That wasn't just to Madison, that was to everyone. Madison's like, yikes, I speak, and then she asked me another one. Anyone have an idea?
Well, I feel like you should be able to in some situations, but with this like manipulative, you only have the option to increase it by 1 or an even number.
Exactly.
Yeah, okay.
Yeah. Okay, so if you want to investigate it further, we know that 1 square has an area of 1 square unit. If you looked at this figure, think about this figure. First of all, what's the area of it? It's not a trick.
6.
Yeah, 6. And if we know that's square centimeters, we would say the area is 6 square centimeters, right? What's the perimeter of this shape?
Would it be 10? Wait.
12.
Yeah, it's 12. It's hard when you have to count it that way. So the perimeter would be 12 centimeters. Okay, everybody okay so far? All right, now if we talk about, because I like Hannah saying, well, maybe this is just a particular circumstance, right? Because it's on this grid paper. So there's our 6 and our 12. Can you add a square? So now we're not talking just perimeter, right? We're saying, can you add a square to this figure so the perimeter doesn't change? Think about it. Why or why not? You could draw this on a piece of paper. Can you add a square so the perimeter does not change?
I think you can.
Okay, Betty, where do you want to put it?
On the top right.
Top right. So right here?
Yeah.
Okay. Do you agree that now my area has increased? Now my area is 7 units or 7 centimeters squared. But my perimeter is still 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do you agree? Nice. Now, I could have put it somewhere else and changed the perimeter, right? Like I could have put it here, and then my perimeter would change and my area would change. Yeah. But I didn't put it there. I put it where Betty figured out it should go. So like this, can you add a square tile to the original figure so the perimeter increases by 1 unit? Well, sure. If I put it right here, I've increased it by 1 unit. Yes? Have I increased it by 1 or have I increased it by more than 1? Just because that's where I drew it last time, so I wanted to make sure. I'm not saying this is right. I'm just saying I just drew it on the other slide, so I wanted to make sure you could see it here. How much did I increase it by here? Okay, it's 7. The area is 7 centimeters squared. What's the perimeter? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my perimeter is 14. So I didn't increase it by 1. I increased it by 2. Yeah. I only increased it by 2, Kelsey. Do you see why I only increased it by 2? Because this line moved here. So it only counts once because we're only counting the distance around the outside. So I increased it by 2. Yeah. Thanks, Brianna. Okay, so can I put it somewhere where I only increase it by 1? Think about it. All right, and then it says, can you do it so you increase it by 2? Yeah, just did it. Can you do it so you increase it by 3? What an investigation that would be. So here's your discussion question, or just what that you can think about. I think when you increase the area, the perimeter increases too. We know that's not true. We just proved it, right? So Joni's wrong. Think about how you would explain it to her. This is what I wanted to get to before we leave. This is your discussion board activity. Yes, it's called the Oink Rectangular Pen. So Anne Marie and Emily are planning to build a rectangular pen for their pot-bellied pigs, Piggly and Wiggly, using a specifically designed wood fencing that's measured in feet. They're unsure of how much fencing to get, as their conversation below reveals. They need a lot of room to run around, so we should make the pen as large as possible. You mean we need to have the pen to have as much area as possible? Does that mean we have to buy a lot of fencing? I'm not sure, but we don't have a ton of money to spend. We need to get the most area out of the fencing we can afford. I'm not sure what it will look like though. I'm not sure either. So I made a Jamboard for you that you can use. You can make a copy of for your group. For your, it's the discussion board's not a group, but I made a Jamboard so you can make a copy if that'll help you with your discussion board. Okay. Now, each team, the teams that you were just on, have a different amount. So teams 1 and 2 have a total amount of fencing of 72 feet. Notice it doesn't say 72 square feet. That's not true. You're buying linear fencing, right? So you have 72 feet. Teams 1 and 2. Teams 3 and 5 have 60 feet. Teams 7 and 8 have 33 feet. And team 4 and 6 have 50 feet. So for your assigned length of fencing, sketch some rectangular shapes, give the dimensions of the pen, record these, and then make sure you compare after you decide what's your maximum area, compare to the other students and think about, especially compare to people that had different measurements than yours. Yeah. So if you had 72, maybe look at 33. Describe the shape of the rectangles that have the least amount of area and the most amount of area. So, and then a common misconception is when you increase one, you increase the other. If you investigate this, you will notice that it's not true. So that's what you're going to do on your discussion board. This developing area formulas is an assignment that you're going to work your way through. Okay, I made it a separate slideshow called Developing Area Formulas that's attached to that assignment. Make sure you follow the directions. If you want to, you can click on the interactives because it'll help you see what you're supposed to get. Okay. All right, so this is really long, but you work through it on an assignment. Okay, I know that was fast, but I want you to do your exit ticket. If you get it wrong, don't be upset. We went through this very quickly. And then I will see you tomorrow. Tomorrow we'll do a little bit about area and then we'll move on. Okay. See you later.